The consequence of that is all you can do is compare two conditions. You can never say there was this exact amount of metabolic activity right there. You can only say it was more in this condition than that condition. Okay? All right. So those are the major caveats. Nonetheless, we can discover some cool stuff. Okay. So let's suppose, to get back to face recognition, you wanted to know, is face recognition a different problem in the brain from object recognition, right? If it was, you might want to write different code to try to understand it from the code you're writing for object recognition. It's something you'd kind of want to know, okay? So here's an experiment I did, 20 years ago. Anyway, simplest possible thing, so it's an easiest way I can explain to you the bare bones of a simple MRI experiment. You pop the subject in the scanner, you scan their head continuously for about 5 minutes while they look at a bunch of faces. For 20 seconds, they stare at a dot, they look at a bunch of objects, they stare at a dot. Okay, 5-minute experiment, you're scanning them that whole time. And then you ask of each three-dimensional pixel or voxel in their brain whether the signal was higher in that voxel while the subject was looking at faces than while they were looking at objects. Okay, and when you do that, you get a blob. I've outlined it in green here, but there's a little blob there. This is a slice through the brain like this. That blob is right in here on the bottom of the brain. And the statistics are telling us that the MRI signal is higher during the face epochs than the object epochs.